Hello and welcome to Words Analogies and Visualizations in Python, Natural Language Processing Explained for Beginners. I'm your instructor Kashif Murtaza from AI Sciences, and in this particular video we are going to basically discuss word representations very briefly, but then we will discuss how to word representations because the word representations will be in vector form, so how can we define similarity or dissimilarity between two words? What are the popular notions like cosine similarity? Then we will see very interesting relationships, sometimes known as analogies. And we will see a very beautiful way of visualizing these word representations. And we will do all that stuff in Python at the end. So if you're new to our channel, just a brief introduction. At the platform of AI Sciences, we actually deliver or actually provide a lot of services related to artificial intelligence and data science in terms of courses, in terms of software, in terms of consultancies and whatnot. So please check out our link in the description and just explore the new world of artificial intelligence and data science. And if, for example, you are a regular viewer of our channel, then be ready for another very fascinating video from the platform of AI Sciences. So let's begin. First of all, what is embedding? We already have made a video, and the video is available on our channel based on the title of the video is word embeddings. Embedding you can think of as a synonym of point in a feature space or feature vector. There are several ways to convert the words to numeric form, and not just one number, but a vector of numbers, for example, several numbers. Maybe 2, 4.9, minus 3, and so on. And this vector may be a representation of a word, let's say bad. Maybe there may be another word like good, having a representation in the form of vector of numbers. The total numbers here in this vector is known as dimensionality of the embedding space or feature space. And there are several algorithms to actually come up with embeddings given a large corpus of data. We discussed in our earlier video one way, which is known as the singular value decomposition based methods, also known as latent semantic analysis, and sometimes also known as latent semantic indexing. We discussed that to compute these word embeddings. But the other embeddings, they do also exist. Very famous embedding. One of the very famous embeddings are word to vec, glove, fos text, and there are some dynamic embeddings as well, like BERT and so on. But at the end of the day, each word is represented by a vector of numbers in a space. We call it as the words are being embedded in a space. So for example, think of this space as a very maybe a very large dimensional space, maybe a 100-dimensional space, and each point here is represented by 100 coordinates. These are the 100 numbers, for example. And for example, this word travel has is a point in this 100-dimensional space. Similarly, a word feeling, word relative, and so on. So that's what embedding is, and for more details, please check out our video on embeddings. Now, once we have two words, like word A is represented as a vector. Let's say the word bad is represented as a vector, and we have another word like worst, also represented as a vector of a lot of numbers, depending upon the dimensionality of the space. There are several ways to compute similarity and dissimilarity between the words once they are already represented as vectors, like they are embeddings now. One very common similarity measure is cosine similarity, and it works as the following. You just take the dot product, which means you just take the pointwise multiplications, the first coordinate of A multiplied by the first coordinate of B, then the second coordinate of A is multiplied by the second coordinate of B, and so on. And at the end, all these multiplications, they are added up. This is known as dot product. And dot product is one way of finding out the similarity between two vectors. But one problem with dot product is that if any of these vectors has a larger magnitude, if I just scale these vectors with a positive number, the dot product or the similarity measure become increased. To get around with this problem, one way is to just normalize the vector to come up with a unit vector, which is just the vector divided by its magnitude. Now it's just a direction vector having magnitude just 1. And then you get the second vector normalized. That is, and now you take the dot product of these unit vectors, and that dot product really is a cosine similarity. It also represents so this measure also represents the cosine of the angle between vectors A and B. And the smaller the angle is, the larger the cosine value is. So that's about the cosine similarity, very famous similarity measure. Although this is not the only one, but that's most famous similarity measure used to measure similarity between two words. Now, analogy is very, very interesting kind of a concept. And it turns out that several embeddings, they actually were able to discover a lot of relationships, analogies between different words. Think for example, king is in some embedding space or feature space. King has this point, and the word queen has this point. And this vector, this red vector, is actually queen minus king. That's the vector. Similarly, this vector, red vector, is basically woman minus men. It turns out, if you see from here, it turns out if in the vector of king, this vector of king, if I add this vector, then I come up with a queen, the word queen. That's amazing. So think, for example, king plus the vector woman minus man. If you do that, if you just add this vector from here, you end up at queen. So that results in queen. If I rearrange this equation, that may become more intuitively understandable. So think about king. So rather than writing plus woman and minus man, just write minus man first and then plus woman. Now what happens here is king is an entity, and if you subtract the gender from the king, whatever left is only the royalness or the royalty. And genderless royalty, if a gender is added as a woman into it, you get a queen. How beautiful. And these kind of analogies, they actually are discovered. So for example, if you get embedding or representation of king, and you add this particular vector, think a vector for woman, think a vector for man, and a subtraction is also a vector. And the vector for king and this particular vector, you add these two vectors and find out, using cosine similarity, find out in your corpus this vector is most similar to what word. And you will get very interesting relationships now. We will see shortly in Python as well. We will code this in Python, no problem. There are several ways of, for example, visualizing the words using embeddings. One way is you pick a word, for example, good, and then find out the cosine similarity of good with all the words in your vocabulary, and see good is similar to what words, and just list them in the sorted order with respect to the similarity. That's one way. Another way is to group the words based on some clustering algorithm. I mean, just make the groups of different embeddings together and see what words they are similar. Another very powerful method is to reduce the dimensions of your embedding space and bring them down to 3 or 2 using some dimensionality reduction algorithm, maybe PCA or TSNE or some dimensionality reduction tool. And in this low dimensional space, either two-dimensional space or three-dimensional space, one can visualize just as a scatter plot. And in this case, we will see shortly in Python as well that the words that tend to have some similarity, some class, they will actually be placed together. We will see that in visualizations. And that whole tells that how good our initial embeddings are. Do the embeddings, they really capture the meanings of words with respect to their context they appear or not? Okay, so here I'm going to use Plotly package interactive plotting. Pandas required for this Plotly, the way I have plotted. NumPy needed always. For dimensionality reduction, I'm going to use PCA. You can use some other dimensionality reduction as well. And I'm also going to use DLL package for persistency, for saving and loading variables later to use. And these two functions, save model and load model, just are used for saving any number of variables you want on a disk for later use or loading them. I already have loaded this variable, like this word to vec model with 100 dimensions. This was generated by Christopher Manning at Stanford. I have loaded this model. Let me just show you this model. And if you see the embeddings, there are 4 lakh words, each with 100 numbers. And if I just show you word to index, so given a word like good, what is the index of this word in the embeddings? That index is 219. So if you want to visualize if you want to see, for example, 219, so that will be a vector of 100 numbers that represent this word good. And similarly, we have 4 lakh such words. And these are all the words, and this is a dictionary from mapping word to indices, and this is a dictionary from mapping index to words. So after that, this is a function for defining the cosine similarity. If we give the whole embeddings, all the embeddings, and if I give a vector, then it first normalizes the embeddings and the vector, and then computes the dot product, simply the dot products, and returns this vector, the similarity scores of all the vectors in our vocabulary, and also returns the indices which it is the most similar to. And then we can see what is the first most similar to this V, what is the second most similar, and so on. So that function. And now let us just find out let us just find out the 10 most similar words to the word fool by calling this most similar. Let's see. So in this case, the most similar word to fool is idiot, fools, joke, dump, guess, damn, yourself, or whatever. And let's have, for example, game. And the 10 most similar words to game is games, play, season, player, players, match, scoring, playing, playoffs, and so on. So you can just see, these embeddings they're really amazing. They actually learn that these words, they have some connection and similarity with this word. If you, for example, go to a word good, you get better, sure, really, kind, very, we, think, and so on. Obviously, there are some noisy words as well, but most of the things are really amazing. Next, we focus on analogy. So this is our E, the embedding matrix for all the words. This is word, let's say good. This is word, let's say fantastic. And this is word, let's say bad. Let's say. And that's the vector we come up with according to the analogy that we discussed here. For example, king minus man plus woman. So think this king as this word. So this is king. This is being subtracted. And then king plus woman, they are being added, just to get the idea. And then I'm going to find out the cosine similarity of this vector with all the vector. and then we will see which one of these is the most similar. So let's see the amazing results here. So for example, good is to fantastic. Then what is bad? Bad is to what? So bad is to, oh, how is that? Good is to fantastic. Bad is also to fantastic. That's amazing. Very, very kind of strange result. Fantastic. That result shouldn't be there, but somehow it is there. It should be kind of terrible or something like that. But let's see the result like this. If we, so cow is to cows, then cat is to cats, and that's a similarity score. Let's see another one. I mean, you can expect certain errors here. There are biases also. So Japan is to Japanese, is Australia is to Australian. And let's check one more. Tall is to tallest, then long is to what? I guess it should be longest. Yeah, let's see. Yeah, longest. So that's how you can come up with these analogies, and it's very simple operations in vector math. Next, what we do is we sample some words with this. We sample some of the words, let's say these words, out of all the embeddings, reduce this dimension using PCA, and then just plot them and see whether related words or the similar kind of words they are nearby or not. So you can see the details of these functions. The code file will be available. So these are, let's say, some words to sample. Let's just pick those words. Yeah. And sample those words, reduce their dimension. And after reducing their dimension to just 3, let me just plot these and see what are the relationships for visualizations. Maybe we are going to see very cool visualizations. So yeah, so if you, for example, see this 3-dimensional plot and see this one cluster, you can see these are kind of countries. Yeah, these are countries, they are placed nearby. And if you see this cluster, these are also countries, and these are also placed nearby. If you go there, oh, these are kind of living beings like animals, parrot and kangaroo, and they are placed nearby. And if you see here, these are meals and they are placed nearby. If you go there, this is test, this is a problem, this is tea, this is a class, this is wine. And so for example, if I just go there, so this is assignment, this is water, this is a problem, assignment, and beer, tea, coffee, homework, and so on. So if I just zoom in and I show you some nearby things, let's say here, so tea, coffee, wine, water, beer, champagne, these are related words, yes. Then brandy, Rome, pizza, sushi, spaghetti, yeah. So let me actually give you some more, maybe somewhere. Let's get it to the home location, and let's zoom here and see what are these things. Problem, assignment, oh wow, homework, class, test. Oh, these are nearby. They should be. Let's have these two. What are these two? School, college, university. You can see, these are making these kind of clusters there. And you can sample more and more points and can have visualizations. One way is to just sample the words first and then reduce their dimension. The other way is to find out the dimensionality reduction first of all the embeddings and then just sample the words and see the similarities. And that's just one way of visualizations and building the analogies and so on. So that's about it for today's video. I guess you have enjoyed this video. If so, please subscribe our channel, share this video to your friends, and like our video. Press the like button. I mean, liking means physical likeness, like press the like button. Yeah, hope to see you with much more beautiful and exciting videos next time.